Good day everyone. Myself Manas Upadhyay. I am currently pursuing construction engineering and management from the SEPT University. I am currently in my fourth semester. During this semester we have to do DRP and I have done my DRP in Shapunji Palonji company where my guide is Dr. Jyoti ma'am, which is respected faculty from the SEPT University, Mr. Aritra Roy and Miss Swarali Nijme who is working in Shapunji Palonji company. So I will presenting on the last planar system in the context of commercial building project. The objective of the research is to explore how LPS improve efficiency, predictability and project reliability, particularly when integrated with automation tools. So this is our research timeline of our DRP during January to April, which is consists of 16 weeks, which follows a structural approach across 5 phases. In phase 1 of 4 weeks, which cover literature review and methodology. During phase 2, which is also 4 weeks, involves case study and comparative analysis. In phase 3, we focus on data, synthetic and site involvement and best practices. In phase 4, we establish KPI like PPC, percentage plan complete and validate we have finded. In phase 5, we conclude our report writing and presentation preparation. This timeline ensure a systematic study of LPS implementation in construction project. Now we will study detailed LPS which we have done our DRP. So now moving to the project brief. As I am working on a building project and my sector is a commercial project. So my main purpose is to explore how the last planner system improve efficiency in commercial building project. And we have also created a dashboard for where we track plan versus actual outcomes, which also improve the project manager to make data driven decision based on the real time information. And my main aim is of the research to develop an automated dashboard for real-time monitoring of plan versus actual mandates, delay analysis, and productive evaluation in commercial construction project using LPS. And the objective of my project is in commercial construction project, the dashboard will facilitate real-time tracking of plan versus actual. And the automated system will reduce manual reporting efforts, minimize human error, and provide immediate insight into project manager, which will lead to more efficient and data-driven project execution. And the outcome is enhanced proactivity, decision making, and reduced delay, improving project performance. So now moving to the literature review. As we know that Indian construction industry has been grappling with challenges such as project delay, cost overrun, and inefficient workflow. In traditional project management approaches, often short in addressing this issue. So the LPS developed by Ballard and Howell in early 90s has emerged a prominent lean planning and control system aiming at improving workflow reliability and project predictability. The LPS is production planning and control system that widely adopted in construction project to improve reliability and workflow. This system involves 4 levels: planning, master schedule and phase schedule, and look ahead planning and weekly planning. This collaborative nature of LPS encourages the involvement of all stakeholders, fostering better communication and coordination. To identify important topics, data sources, research techniques, and analytic framework, the research methodological approaches was created to examine the LPS in commercial building project. The first step was compiling academic and industry specific materials such as case study, technical report, conference proceeding, and peer review publication. Public like Journal of Construction Engineering Management, the ILCC, ASC were example of primary source. In order to extract best practices, the publication from group of construction industry and conference paper of international group of lean construction were also examined. We have seen that we start from the make promises, make work ready, specific handoffs and set milestones works in LPS component. In master schedule, establish overall project schedule and timeline. In phase schedule, we break the master schedule in detailed phases, facilitating better coordination among stakeholders. In look ahead planning, we identify removing constraint in upcoming tasks, typically in 4 to 6 week window. In weekly work planning, involve frontline supervisors in committing to specific tasks for the upcoming weeks. In learning and continuous improvement, encourages reflection on complicated tasks to identify area of improvement in future planning. The benefit of LPS in commercial construction project, it improves the planning reliability by involving those closest to the work in planning. LPS enhances the accuracy of schedule. It also reduces waste, proactive identification and removal of constraint, minimize delay and resource wastage. It also increase productivity in streamlined workflow and clear task assignment contribute to higher efficiency on site. The main challenges in implementing LPS is despite its benefits, several challenges appears in LPS commercial project. Resistance to change. The traditional project management culture may resist the collaborative and transparent nature of LPS. Training requirement also is an issue. Effective implementation of LPS, we need a training, compulsory training for these principles. Then integration of existing system. Alignment of LPS with pre-existing project management tool can be complex and may require a significant adjustment. An inconsistent application, like partial or inconsistent application of LPS component, can lead to sub-potential result. And we have done the case study of three. In first is Mumbai Metro Line package. The implementation of LPS in this underground metro rail project lead to increased productivity and cost reduction by identify waste and non-value adding activities. In the second research paper, we have referred Bishop Hyber College construction in Tripoli. The application of LPS in construction multi-purpose building improve performance and productivity through better planning and coordination. The third research paper we referred Manipal University, Jaipur. LPS implementation in these highlighted its improving workflows and control, leading to enhanced productivity. We have also digital tool we can use in BEAM and LPS integration. Combining BEAM and LPS has so promises improving visualization, coordination, and real-time decision making in commercial construction project. Automated planning system can be done by development of dashboard and planning tool alignment with LPS principle and real-time tracking and contribute to more informed project management. We have also done like that, created the dashboard and automated for the LPS. We can say that in planning reliability, collaboration, waste reduction and productivity. However, successful adoption require addressing challenges related to cultural resistance, digital tool argument, efficiency of LPS, paving the way more efficient and predictable commercial construction process. Now moving to the case study, we have referred the four case study. The first case study which is done in Tiruchupalli, where lean is also complicated, where the study conducted by Vignesh explored the application of LPS in multi-purpose building project in Tripoli, where LPS was introduced midway into the project to assess its impact and project performance. The literature review criminally examines the implementation process, challenges, success factor, and key finding of the study. The research follow action research model where the study compares traditional project management technique with LPS driven planning and execution. Highlight improves in working management, schedule reliability and communication efficiency. The context of that, the project is of total 8 crore where LPS is implemented. The duration of that is 22 months. To evaluate the impact of LPS on project performance and analyze the barrier affected is full potential. And weekly control in implementation is also significant challenge during to implementation. Limited subcontractor coordinator, a communication between different subcontractors create insufficiency. Delay implementation, LPS was adopted midway causing resistance from stakeholders who were accustomed to traditional project management approaches. Limited influence over all our projects since somehow contractors were nominated by the client. The contractor had limited control over the adherence of LPS principle. Skilled labor shortage is also there where a lack of availability of skilled workers particularly during finishing stages led to frequent task repetition affect project timelines. Physical workers involvement, field workers were not actively engaged in the planning process resulting in difficulties in executing weekly work planning. Where success factor we identified is that management commitment and support. Top management involved was the key driver in overcoming resistance to LPS adoption. And the CEO active participated in monitoring PPC, ensure continuous improvement. Then the weekly PPC tracking and public display of result encouraging and improve stakeholder commitment. The introduction of cloud user group CUG for mobile communication improve site coordinator reduce delay. Training initiation for stakeholder in bridging knowledge gaps related to LPS implementation. Worker incentive and motivation is there where bonus was introduced to encourage better participation, peaking PPC at 121% in certain weeks. Performance based reward motivation subcontractor site personnel to align LPS. The key finding which we identify in this project is the pre-implementation PPC was 37.5%. The post-implementation PPC increased to an average of 85% with some weeks exceeding planned targets. Where common causes of incomplete assignment are there that material unavailability due to supply chain and disruption, unavailability of skilled labor particularly in finishing works, changing priorities in client induced modification that disrupt planning schedule, training knowledge and gaps were found at where majority of construction professionals lacked awareness of LPS and its principle. Some aspect of LPS such as look ahead planning and phase schedule planning were partially implemented or skipped. We need a LPS administration where emphasis of LPS implementation for the project inception who would have better results made association and integration challenges. The second case study we have find that where we have LPS challenges in under Bhargav Dave sir. The LPS, which is based on implementation challenges, observation from 5 major construction firms in the UK and Finland. Detailed case study done is from UK and specific in LPS adoption. Categorization of major challenges and potential solution which we identify in this case study. The recurrent challenges in LPS implementation was highlight adaptation, particularly development in LPS component. Major organization only implement weekly planning and neglecting look ahead planning and phase schedule. Lack of proper collaborating planning and disjoint workflow. Weak integration between that is done where detailed look ahead planning, and also the lack of phase schedule result in poor sequence and constraint management. While LPS emphasizes collaboration, many organizations fail to involve all the subcontractors in planning meetings. Planning is often conducted by the site manager alone, limiting transparency and coordination. Lack of standardization in report is done. The flow of information between high-level planning and short-term execution is often inconsistent. No structured feedback loops, like leading to insufficient constraint management. Weekly monitoring and control mechanism, tracking and updating workflow constraint remain a challenge. However, reliance on Excel spreadsheet making real-time coordination difficulty. The 5 major observation we have find that study examination level common weakness. The there are 5 company where phase schedule is not complicated. In the 5th company it is implemented. Look ahead also planning also implemented in 1 or 2 company, and weekly planning is implemented in every company. Collaborative planning is done in 2 or 3 company. Continuous improvement is not done in any company. So from this case study, only one company fully implemented all aspects of LPS. Phase schedule was rarely implemented, leading to subcontinental workflow. Look ahead schedule was either partially implemented or skipped in many cases. Tracking mechanism of continuous improvement were largely absent. So key finding we can say that in this LPS implementation is lack of accountability among stakeholders due to poorly defined responsibility. Project manager and site supervisor struggle to adapt to LPS, leading to confusion about project planning. Inconsistent collaboration between subcontractor leading to insufficient task execution. The critical success factor for LPS, we identified that project manager implemented all levels of improved coordination workflow efficiency, regular progress on monitoring and reduce reliability. And also the cross pattern analysis we can get limited understanding of collaborative planning, weekly planning, skip, look ahead planning and construction analysis. So we can recommend that for LPS is trend long term and collaborative planning, improve monitoring and feedback mechanism, standard training and LPS implementation guidelines, develop structured training program for project team to ensure consistent understanding of LPS team, introduce standardization reporting template for tracking PPC. Many are not using Beam, so use Beam for digital system automate and workflow, integrate task sequence and real time progress. So now we can move to the case study 3, which is done in Hyderabad, which we have referred the reference paper of Abdul Manan Hussain. This study focus on improving workflow, reliability, productivity and stockholder collaboration in by employing lean construction principle. So the review critical examine the project type, scope and implementation framework and challenges we have identified. The type of score is a Hyderabad project. The value of the project is 46.99 million. The stakeholder involvement in school management, project manager, contractor, subcontractor, site engineer and laborer. And the duration of project is 17 months. So the LPS is applied in 3 phases: structure work, superstructure work and finishing work, where the study utilized look ahead schedule, weekly work schedule and percentage plan complete and training to enforce project efficiency. The while monitoring before LPS, PPC was recorded 45%, indicating high workflow variability and frequently task failure, where PPC increased to 77%, reflecting to overall improvement to 71% in workflow also, productivity and task completion. So the main challenges we find is design improvement, several challenges were incorrected, resistant to change, labor and supporters show reduced in adopting new process, limited LPS training also we identify in this, stakeholder lacked prior knowledge of LPS, poor documentation and monitoring, insufficient tracking led to delay in constraint resolution, subcontractor and coordinator issue, misalignment of work request and cost delay, design and material constraint, frequently design change, and there are shortage handled process. Strategy used to overcome challenges like stakeholder engagement, regular meeting to improve communication, constant analysis board, pool planning and reverse phase schedule to be done better, task sequencing and demand driven execution. Weekly PPC monitoring also should be do. And weak control areas like resistance to change, lack of training, inefficient control change, material and equipment issue, delay approval. Early construction identification we find in LPS is collaborative planning, improved communication among contractor and engineer and workers, efficient PPC tracking. The impact of LPS on productivity, time and cost also is done. Key finding which we find is that the PPC improvement from 45 to 77%, highly better is stakeholder collaboration in a resolve solution. And we can move to the Colplus, which is a stimulation tool where we identify the digitalization in LPS, which help the Colplus simulation to equip construction professional with practical understanding of LPS, particularly in workflow condition constraint mitigation, where develop look ahead plan and weekly work plan and systematic schedule, simulate real work constraint such weather disruption, material shortage and labor insufficient, measure PPC and conduct root cause analysis for workflow, strength collaborative. Colpla component in three phases: basic data sheet, running plans, analysis sheet. They develop the one dashboard to communicate and to apply digitalization dashboard where defined project activity, crew allocation and productivity benchmark, including 4-week rolling schedule, enabling real-time progress and delay assessment by offering an interactive and risk-free environment. Colplus serves as a powerful both for theoretical and practical occupation. Common barrier in LPS adaptation in Colplus we find is lack of formal training, difficult in identifying constraints, and resistant to change. Traditional project manager hesitate to transition from critical path method to LPS, and limit use of digital tools. Manual scheduling techniques slow down the LPS. And addressing challenges through simulation is providing an interactive training platform for hand-on LPS training, enhancing custom visualization, allowing interactive scenario testing, offering real-time feedback to support continuous workflow. The impact of Colplus as a project performance improvement we find is that PPC from 45 to 60%, which increased from 75 to 85%. The 30% increment is done in Colplus. And time saving is also done in weekly planning schedule. There is high error which we find before use of Colplus, and after that schedule accuracy increased. The success factor enabling Colplus, several factors like that use of interactive visualization tool like PPC dashboard, which is the must and constant analysis map. Early risk identifying is done in this project, and enhanced collaboration, weekly coordinated planning session improves stakeholder and data driven decision making. Real feedback allowed for adjustment in planning strategies. The key finding we find that the project from 45 to 60% is increased to 75 to 80%. In research methodology, first we identified that the project is time consuming and planning engineer has to fill the daily work day manually in Excel, which we show in the process map, which is the main gap we find. For that solution, what we have done, we have used the two automation like macro and Microsoft form, which is done in Excel dashboard for automation, where used Microsoft form for automation. So daily execution person have to fill the form, and daily automated will happen in master Excel, which we have linked into the Excel. So when the site person will fill the form, then the automatically actual days will be released. So the planning engineer don't have to fill the form daily, and use of macro that automated graph will be generated in the end, where plan versus actual for each activity like survey, like reinforcement, like concreting. So for each activity you can generate the graph by we have used the coding in that, so the person don't have to fill the formula again and again, so he can generate it directly. And also in the Microsoft form, the planning engineer has to fill the Excel sheet of actual dates, where he has to go to the sites and check that the task is completed or not. He have to monitor. So similarly we have done like that. The site engineer person will fill the form where all the delay and the questions will be there. He will fill the form daily, and we can generate automatic Excel in the sheet. So the planning engineers don't have to put the data manually. Where we are automatic LPS Excel, the first step is keeping milestone and weekly planning by using Microsoft. The first step will be the milestone and the weekly planning. So we are directly going to the Microsoft form because of the digitalization and use in macro real-time tracking. So the main objective is to create the automated dashboard for monitoring LPS, which is not put the manual data again and again, which will be helpful for the planning engineer. In real-time tracking and where we actual and planned days, and productive evaluation also can be done automatically and digitalization. So automation method. So we use the two method. First method is Microsoft Form for automation, and second method is macro based automation for graph. The middle is the real time storage. So all the data will be saved in Excel and it will be saved in OneDrive or SharePoint. So the data will not be displaced. So in first that we have used the Microsoft where data entry from construction site will be used. So the engineer will be fill the form and minimize error. That planning engineer don't have to go to the site and fill the actual dates, which will be minimize the error and delay and smart input from tracking key projects, and that directly will be stored in the Excel. In macro based graph automation will be done, which will be helpful for Excel VB automate generation graph. So for example, there is a one sheet, dashboard sheet, and you have to create the graph. So you have to create the graph, select the activity and do the again and again. So we have generated the code in that Excel based sheet, and for the survey, for the enforcement, for the concrete, just you have to put the codes SU for survey, RF for enforcement, for the or activity which is done in the Microsoft Excel, and it is done in the MSP also in Primavera. So we can generate each activity graph and we can see the productivity of each and every activity, which will be helpful for that. And also that for the summary sheet, the actual dates which we will find and putting the formula again and again. So if you give the code SU for survey and RF for enforcement, then directly the numbers will be come. It will take from the dashboard. So don't we have to put the formula again and again and take the activities total. So it will be helpful for the automation method. This method will be done, and the Microsoft form is the must that the site engineer has to fill the form daily. If he miss the form in between, then the planning engineer can be check that the form that the fill is not formed. So on 2-3 days that he can check and confirm that why this delay is occurring on that day. So he can complete this activity. So now we will explain the detail base of method 1, which will be explained in the detail. To address this challenge, a form-based data collection system was created, a centralized digital mechanism. So we can see in the flowchart that every activity executed on site is recorded with actual manpower deployed, its status, whether it's not incorrect or delayed. So we create the design and development of form in which the project date will be there, activity code will be there, actual and manpower for the activity, status of the activity which is completed, ongoing or delayed, delayed flag. If the reason is yes, then the reason will be form like material, labor, drawing, approval, etc. So this will be data will be in the form. So we have created the form which will get seen in the right side. This is the main the form. And the role of form in automatic actual manpower tracking is to apply the improving real-time project. So first we will fill the sheet 1 data entry Microsoft form, then we will transport the sheet. So automatically the transport sheet will be done. In third step we will see the main sheet where will the main dashboard will be there day wise, day 1 से लेके day 30, and there will be date also. In that role of Microsoft form in automating manpower tracking is verbal communication gap will be fulfilled, manual entry errors will be fulfilled, delayed sharing of daily report, misalignment between field activity and office record. And strategic benefit of Microsoft form based system is that uniform reporting, real-time update, delay intelligence, automatic ready, adaptable format, in no specialized software needed. So directly site engineer will fill the form and automatically data will be changed in the Excel sheet. And we have also given the color code. For blue light color code, the plant data entries is there, which will be filled by the planning engineer before starting the project. And the orange light is actual data. For actual data, planning engineer don't have to fill the form, just he have to check that the site engineers have filled the form or not, and he will check that this activity is completed or not. And the summary sheet is also automatically will be updated up to this. And we have given the summary table like SU for survey activities, SF for safety, RF for enforcement, SH for shuttering, and MEP for MEP work. So automatically the plan versus actual date will be confirmed, and daily updating chart creation will be done where show the plan versus actual in use of blue and orange color, and we can face the deployed or deployment by activity. and the variation chart is also created based on the dashboard. And we can analysis like the plan versus actual, where we have distribution the shuttering and destructuring graph also. Now we will move to the method 2. So before moving to the method 2, we have shown that blue or orange color like planned dates and orange color is for actual date. This is a variation chart, and this is the main table where day wise is there, day 1, day 2, day 3. For the every month the data will be there. The planned activity is already filled. For actual date, the planning engineers don't have to fill the form. From the Microsoft form, when the site engineer fill the form, the automatically data will become for the actual dates. And if the one day is missed, the planning engineer can see and check that from day 5 the data is not filled. From the day 8 or day 9, whenever he check, he can go on the site and check that why this day the form is not filled and the task is completed or not. He can check and verify it, and similarly the process will be going on and the task will be completed. It will be reduce the human error, and it will also reduce the work of planning engineer. So now moving to the method 2, where we use the macro. In that we have done the coding in VBA. So that coding help to generate the graph directly by using the small codes like SU, SF, RF and SH for each and every activity. The process we have done, that we have started from Excel based macro using code to generate automation, giving keywords, automatically update manpower in summary sheet, similarly generate the graph for productivity, actual versus plan. So which we have shown in this flowchart, and this is the main table of where we detail summary table will be completed. For column A, activity ID is there. For column B, activity description is there. Column C, type, actual versus plan. Column D, shift like forenoon or afternoon. Column E, main days, and column F to Z, where planned main days are retrieved from pre-recorded project data, and actual dates will be automatically updated from the dashboard by giving the codes. And benefit of automation is time saving, no manual entry of plan versus and actual main days, which save significant time. Accuracy reduces human errors. Like for example, if we put the formula or something, error can be happen. By giving code, there will be no error, and it will be time consuming. In real time update, data is updated instantly, reflecting the latest performance. In manual data entry change, time consuming process will be reduced, like for updating multiple activities, calculating the plan versus actual, prone to error. Repetitive manual data entry increase the chances of human error such as incorrect calculation and missed entries. Delay reporting, the lack of amount of automation mean that reporting had to be done manually, often leading to delay in identify productivity trends and discrepancy in activity performance. So during the method 2, this pop-up window where the activity ID is entered with the direct data will become. So the macro automatically extracts the shift-wise labor data, forenoon and afternoon shift for each activity. It calculates the total manpower for each activity by summarizing the shift-wise data. The macro plots a line chart or bar chart showing a planned manpower versus actual manpower using across each activity. Benefits of automation is real-time tracking, enables real-time tracking of manpower consumption against the plan. Resource optimization can be done by project manager identify when and where labor resources are being over and underruled, aiding in more efficient planning. Visual representation also is done for easy communication and manpower trends to stakeholder and team members, simplify decision making. So the impact of automation is Excel macros include the construction project data collection and analysis process significant improvement were made in both efficient and accuracy. The automation of this flowing process, like we can see in the graph, like plan versus actual, the automatic chart generation and easy data comparison has been done. We can see that directly this chart has been came, and no entry will be have to fulfill for each activity, like for shuttering, for reinforcement, for concreting, the direct chart will be pop up, and it will be a less time and discrepancy quickly and take corrective action in timely manner. The automated dashboard related macros are powerful tool that can be implemented in future project to improve operational efficiency and enhance overall project outcomes. So for this comparison graph, like that, step by step we have done the macro productive analysis. First we open the macro dialog by clicking macro in the developer tab. Then we will put the code, they enter the activity. After selecting the macro, the system will prompt you enter the activity ID. So if we fill the form of activity ID for RF, then the quantity will come for enforcement installation in the system will ask the quantity. So the quantity will be shown in the chart. Output and the graph generation is the quantities enter the macro, perform the calculation and automatic generate the corresponding graph. The graph help in understanding the productivity level of activity. The automated result will be come, and the bar chart provides a visual representation of productivity, making it easier to analyze the performance trend. So this is the axis we can see in that the reinforcement installation, x-axis, y-axis, and bar chart. The benefit of automation is quick visual insight. Planning manager can quickly identify discrepancy and between plan and actual mandate using this chart. Enhance communication. The graph can be used for communicate performance data to stakeholder in a clear and easily digestible format. Real-time monitoring. As data is updated in real time, the graph provide an accurate ongoing visual representation for project performance. The future scope for improvement, that automation, data integration can be done, error to prevention, user training, mobile compatibility. What happen if a person misses a date? Then date gap. If a person misses a date, it leaves a gap in the data leading to incomplete record, which can afford productivity analysis and project reporting. Inaccurate reporting also can be done if the site engineer not fill the form. Missing dates mean that project actual progress or delay won't be accurate reflectly, which can result in misinformed decision. Difficulty in tracking also can be done. The missing data can be harder to take productivity or delay, potential delaying corrective action or project adjustment. Delay updated. If the daily updates are missed, it could be lead to delay insight and report affecting a project management decision making. What if the phone need to be corrected again from start to take a lot of time? Then wasted time, data loss will be done, manual error can be happen, delay in reporting, increased workload. So in conclusion, we can say that by incorporating Excel macro into the construction project, data collection analysis and significant improvement were made in both efficiency and accuracy. But the form should be filled by daily wise. The plan versus actual maintenance will be there, productivity comparison will be there, and manpower variation chart will be there. So for this, these two methods will be used in our research paper, and these two methods will be help for any industry to complete the project on time and accuracy and less human error. So in the end, we can move to the conclusion that this research paper explored the implementation of the last planner system in commercial construction project, integrated of automation to reduce manual work and improve project management. By using Excel-based automation tool, including Microsoft Form and Macro, the study demonstrate how real-time data can be tracking and enhance the project monitoring. While LPS show benefits in improving planning accuracy, reduce delay and enhancing collaboration, challenges such as resistance to change, lack of training, and integration with existing system remain. The study highlights the importance of digital tools in optimizing LPS, making construction projects more efficient and predictable. The key learning we find is that efficiency throughout automation, like the automating data collection to reduce error and spend reporting, implementation challenge, addressing resistance to change and integrating issue, continuous improvement, ongoing feedback and learning and optimize project performance, then enhance collaboration, improving and communication and accountability among stakeholders, and the digital tool drive success like improving scalability and effective. Thank you very much. I have learned in DRP so much.